Okay, let's look at the homework 5.1, 5.2, number 4, right? So we have acceleration given, second derivative of s of t is equal to negative 32 feet per square second, right? That's the acceleration. And we want to know we want to know what the initial velocity so that the object can reach up to 590 feet. All right, so let's do that. All right, so since we have acceleration, so maybe I should write it as a of t. All right, so a of t. So this is acceleration, which is the same thing as the second derivative of the position function or height function in this case. So this is negative 32, right? So we can find the velocity function. So I'm going to call it v of t, which is going to be simply, we take the antiderivative. So we take the antiderivative of negative 32 with respect to t, right? But we know that antiderivative of negative 32 is negative 32 t, right, plus some constant. So I'm going to call it the C1 because I might have to use another constant. So I'm going to call it C1. All right, so let's find C1. Since initial velocity, so we're looking for initial velocity. So we usually use V0. So initial velocity V0. So V of 0 is equal to, plug in 0, so negative 32 times 0 plus C1, which is going to be equal to, this is 0 anyway, so it's going to be C1. That's equal to V0, right? So we have a complete formula for V of t. V of t is, maybe I'll write it here. So we have a velocity function is actually negative 32 t plus V0, because C1 turns out to be V0, right? All right, then once you have a velocity, which is the first derivative of s, so we can find the original function s of t by taking another antiderivative. So antiderivative of negative 32t plus v0 with respect to t, right? So this is going to give you, right, so negative 32 is just a constant, right? T, so add 1 to the power, so it's a second power, then divide by that number 2. All right, antiderivative of v0, since it's just a constant, it's going to be just v0t, and plus some constant, c2, right, some constant. All right, an object thrown upward from the ground. So this tells you that s of 0, right, we're assuming that ground level is 0, so it's 0, right? So plug in s of 0, plug in t equals 0, right? Oh, actually, I need to simplify this. So this is going to be 32 divided by 2 is 16, right? So it's a negative 16t squared plus v0t plus c2, right? So it's going to be negative 16 times 0 squared, which is a long way of saying 0, plus v0 times 0. So actually, maybe I shouldn't, yeah, it's okay. v0 times 0, which is 0, plus c2. Is of course, this is 0, that's 0, so it's just going to be c2, but which is supposed to be 0, right? So this is equal to 0. Right, C2 is 0. So you have a complete formula for S of t, except that we don't know V of 0, is a negative 16 t squared plus v0t plus 0. So that's that. All right. Then what we want to do is we want to make sure that this guy is going to reach the height of 590 feet. All right. So remember that. So here's the ground. All right. An object is thrown upward, and it comes back down at some point. Right. So we are looking for this initial velocity v0. So this is what we want to find, right? But we know that at this point, when it reaches the highest point, we know that the velocity is going to be 0, because you're going to have to stop and start, come back down, right? So why don't we set v of 0? So velocity equal to 0. So velocity is right here, negative 32t plus v0, right? We set that equal to 0. All right, then subtract v0 from both sides, so it's negative 32t is equal to negative v0. Then we can just divide through by negative 32 to get that t is equal to v0 over 32. Right? So at this point, time is v0 over 32. All right? So we want to make sure that at this time, the height, the position function is going to be 590. So let's just plug it in. So position function s at the t is v0 over 30 is going to be equal to, all right, we just have to plug it in. So it's a negative 16, all right, v0 over 32 squared plus v0 times v0 over 32, right? Let's simplify that. Let's see. So this is going to be, right, negative 16. All right, I'm going to distribute that square to the top, so v0 squared. And you have a 32 times 32, right? And plus v0 times v0 is v0 squared over 32. All right, you can see that the 32 and the 16 cancel out, so it's going to be 2 there. So you're having negative v0 squared over 2 times 32 is 64 plus v0 squared over 32, right? v0 squared over 32 is 2v0 squared over 64, so this is simply v0 squared over 64, right? So what we need to do is we want to make sure that this is equal to, right, 590. All right, so we're going to just try to solve for v0. So you have, maybe I should go over here. So let's see. So I'm going to go, sorry, I don't have a lot of room. So I'm going to go over here, right? So first I'm going to multiply both sides by 64, which gives you v0 squared is equal to 64 times 590, right? Then we just take the square root of both sides, right? So v0 is equal to, right, plus or minus, right? Right, square root of 64 is 8. And the square root of 590, I can't do that in my head, so I'm going to borrow a calculator to find it. So let's bring out a calculator. All right, let's type it in. So it's going to be 8 times square root of, oh, that's not it, sorry. Square root of, let me do it. Oh, sorry, I'm choosing a wrong button here. Square root is right here. All right, square root of 590. All right, then hit enter. All right, so it came out to be 194.319. So let's type that in. So bring out the. All right, so round to the 2 decimal places. So it's going to be 194.32. All right, so let's check the answer. All right, it came back and looks like we got the correct answer. All right, that's it. I hope that this was clear.